integers, part 1. The objective for this video, number 1, to represent integers using bean counters, and number 2, to use the bean counters to develop rules for adding integers. Now at this point you need something to take the place of the bean counters. If you're at home, you can use some flat washers and some rubber washers. Maybe you can use pennies and dimes. If you're at school, maybe your teacher has some chips that you can use. If not, take some scraps of paper and put pluses and minuses on the scraps of paper. Now, before we actually start using the bean counters to represent integers, let's remind ourselves of what the integers are. The integers are the set of numbers using 1, 2, 3, 4, 5. Their opposites, -1, -2, -3, and the number 0. If I write that using set notation, the 3 dots at the beginning indicate that the integers do not have a beginning point. I have some numbers that are integers, and I finish up with 3 dots to indicate that the integers have no ending place either. Now, since the objective is to use bean counters to represent the integers, +1 can be represented using a yellow bean counter. -1 can be represented using a red bean counter. Any other integer can be represented using some combination of either red and or yellow bean counters. So let's start representing integers to make sure that we can do this part. I want to represent the integer +7 using the bean counters. Now, since the 7 is positive, I need to use yellow bean counters. So in my pile of counters, I need to slide over into my workspace 7 yellow bean counters. 2, 3, 4, 5, 6, and 7. So this is how you represent the integer +7 using the bean counters. To represent the integer -4 using the bean counters, I need to use the red counters this time because the 4 is negative, and I simply go into my pile of bean counters and I slide over 1, 2, 3, 4 red bean counters, and there's a representation of the integer -4. Now 0 is a strange number to represent with the bean counters. First of all, many people think the number 0 means nothing. And with that idea, leaving a blank workspace would be one way of representing the number 0. But I can also use the bean counters to represent 0. If I think back on my science classes, when positives and negatives get together, they cancel out. So I can take any combination of yellow and red bean counters and slide those into my workspace, and as long as I have the same number of red and yellow, I can also say that represents the number 0. So I can slide over 1 yellow, 1 red, and that represents the number 0. If I wanted to, I could slide more combinations into my workspace, and as long as there's the same number of yellow and red counters, that's also the number 0. Now let's use the bean counters to model adding 2 integers that have the same sign. In this example, we're going to add 3 and 5. So since 3 is positive, I'm going to start by sliding 3 yellow bean counters into my workspace. Now, since I want to add +5 with that, I need to slide 5 more yellow bean counters into my workspace. Now, to find out what 3 plus 5 is, simply count the number of bean counters in the workspace, and counting across, 3 plus 5 equals 8. Now let's do 3 plus 4 using the bean counters. Again, since 3 is positive, I'm going to start by sliding 3 yellow bean counters into my workspace. And since I'm adding positive 4, I need to put 4 more yellow bean counters into my workspace. To find out what 3 plus 4 is, all I need to do is count the number of bean counters in my workspace. So 3 plus 4 equals 7. Now what happens if I add 2 negative integers together? This time I need to put 3 red bean counters into my workspace. So 1, 2, 3. And I'm adding to it a negative 4. So I need to move 4 more red counters into my workspace. 1, 2, 3, and 4. Find out what negative 3 plus negative 4 is. Count the number of counters. And I have a total of 7 counters here. And since they're red, the sum of negative 3 plus negative 4 is negative 7. Let's model negative 5 plus negative 8 using the bean counters. Since the 5 is negative, I'm going to start by moving 5 red counters into my workspace. And I'm going to add to that negative 8, so I'm going to slide 8 more red counters into my workspace. 2, 3, 4, 5, 6, 7, and 8. That's a lot of counters up there on the workspace now. And that's one of the reasons why we want to use small numbers in our examples, so that we can figure out some rules that will let us do the bigger numbers without having to use counters. Now to find out what negative 5 plus negative 8 is, count the number of counters up here, and I see a total of 13, and since they are all red counters, negative 5 plus negative 8 is equal to negative 13. Now, pause the video while you think about what a rule would be for adding 2 integers together when the signs are the same. Did you write something like this? When adding 2 numbers with the same sign, add the number parts and keep the sign? If you did, very good, that's right. If you were to look this up in your math textbook, it may say something like this. When adding 2 numbers with the same sign, add their absolute values and keep the sign. That finishes part 1 of today's video on adding integers.